Okay, so in this video, we want to introduce a notion of price elasticity of demand, which we will simply denote as E for elasticity. So so first, how is E defined? Well, E is the ratio of the relative change in demand over the relative change in price. So it's comparing a relative change in demand over the relative change in price. Well, what is a relative change in demand? Well, we have a change in demand, call it dx. If you remember, d stands for an infinitesimal change in the consecutive variable. We use x for demand, the number of items that consumers are willing to purchase. So infinitesimal change in demand x, but it is not the change in demand, but it is a relative change in demand. Relative means that it is the change in demand, dx, over the total demand x. So that is the relative change in demand divided by, well, the relative change in price. So we have the change in price, so an infinitesimal change in price dp, over, well, the absolute price, p. So dx over x, relative change in demand, x, dp over p, relative change in price, p. Well, let's rearrange this to make the quantity E of elasticity of demand more intuitive. So first, let me say if we divide by a fraction that is the same as multiplying by its reciprocal. So this is dx over x. I keep my numerator the same, but again, if I divide a quantity by a fraction, I can, instead of dividing, multiply by the reciprocal, by the inverse, which is now p over dp. I will split up the absolute quantities with the two quantities of change, the infinitesimal change in demand and in price. So I have p over x times dx over dp. And now I will use the same trick that I've used to go from here to here, but backwards. I will keep the p over x as p over x. And if I multiply by a fraction, I can instead divide by its inverse, its reciprocal. So I can divide instead by dp over dx. Instead of multiplying by dx over dp, I can divide by the inverse, dp over dx. And this is interesting because we usually have the demand function, so p is given as a function of x. This is our demand function. Right? The relationship between the unit price for an item and x, the number of items that consumers are willing to purchase. And so this is how we can calculate the price elasticity of demand for a given product. By definition, and this is again more intuitive, price elasticity of demand is the relative change in demand over the relative change in price. But when you calculate it, you use this form, the ratio of the price over x over the derivative of the demand function, dp over dx. Let's look at a key property of this function as a function of x. So E being p over x all over the derivative of the demand function with respect to x. And let's sketch the graph of our demand function. I will be again assuming a linear relationship between p and x, just to simplify the argument. So here's the demand function. The key point is that even though the relationship between p and x may not be linear, it is always going to be a decreasing one. Consumers are only willing to purchase more items if the price is lowered. So even if the relationship between p and x is not linear, one thing that is guaranteed is that it's always a negative relationship, which means that the slope of the demand function must always be negative. But the slope, of course, is just a derivative. So this must always be true, even for a nonlinear relationship. But now look at E. P is the price of a unit, so P is positive. X is the number of units that consumers are willing to purchase, so P over X is positive, over the rate of change of the demand function, which is always negative. So elasticity is the ratio of a positive over a negative number, therefore is always negative. And now let's look at this on an interval, and we will separate the values of E according to three separate categories. So suppose we draw a real line for E. So here's 0. As we've just proved, E is always negative. And the cutoff point for the categories will be -1. So E could be anywhere below 0, including possibly 0. So let's look at the first category, between 0 and 1. So strictly between and -1. So that means that E is bigger than -1, less than 0. If you notice, that is equivalent to saying that in absolute value, E is less than 1. The absolute value being simply the size of the number. So this is an equivalent way of looking at it. Either you think of E being strictly between -1 and 0, or equivalently, E in absolute value is less than 1. If this happens, we say that we have a inelastic demand, or the demand is inelastic. Well, the other possibility is E is exactly -1. Very small, but nonetheless important category. If E is exactly equal to -1, that's the same as saying that in absolute value, E is equal to 1. And in this case, we said the demand is unitary. And finally, the only other possibility is E is strictly less than -1. Equivalently, well, if E is less than -1, then its size is bigger than 1, so the absolute value of E is bigger than 1. And in this case, we said the demand is elastic. And the question is, of course, naturally, why this distinction between possible values of E? Why do we say that the demand is inelastic if E is between -1 and 0, or an absolute value less than 1? Why say we have a unitary demand if E is exactly equal to -1, or an absolute value is equal to 1? And why say that the demand is elastic if E is strictly less than -1, or equivalently that in absolute value, it is bigger than 1? Well, let's look at these three terms. Why the term inelastic, unitary, elastic? For this, we have to go back to the definition of price elasticity of demand. Relative change in demand over relative change in price. So let's look first at an elastic demand. So an absolute value is bigger than 1. Well, as is a fraction, it can only be bigger than 1 if the numerator is bigger than the denominator. So if this happens, here's what it means. Suppose you have a change in price. So you look at the relative change in price over the relative change in demand, units purchased by the consumers. If this is bigger than 1 in absolute value, again, the relative change in demand is bigger than the relative change in price. Now think about lowering the price. So if you lower the price, then you have a larger relative change in demand than relative change in price, which means that by lowering the price, consumers will have a strong reaction to that decision, so they will purchase more items relative to the total number of items purchased compared to the relative change in price. So it means that for a small change, relative change in price, there will be a bigger relative change in the quantity of product demanded by consumers. Opposite of elastic is inelastic, where the same argument holds, but now the ratio is less than 1, which means that the relative change in demand is smaller than the relative change in price. Which means now that if you lower the price of an item, the consumer's reaction will be actually weaker than the relative change in price. Which means even though you might lower the price of an item, the consumer's reaction to that lowering of the price will not be so strong. And when the demand is unitary, when E is -1 or an absolute value equal to 1, then of course the relative change in demand is proportionate equal to the relative change in price. So to make this much more intuitive, when the demand is elastic, it means that as the ratio exceeds 1, for a small relative or any kind of relative change in price, there will be a strong response by the consumers to purchase a lot more items. When the demand is inelastic, for some relative change in price, there will be, so if you lower the price of an item, there will be a fairly weak reaction to purchase more items by the consumers, and when the demand is unitary, the relative reactions are the same. Of course, the argument, and I'll let you think about it, can be made exactly in the same fashion if instead of thinking of lowering the price, increasing the price. And that's it.